Okay. Good morning, everyone, and thank you for attending this presentation. My name is Yonghan Kim, and this presentation is about rule derivation from figures in building regulations using multimodal large language models. So let's begin with the motivation of this research. Traditionally, and even for now, a lot of studies have focused on the deriving rules from texture requirements for automated code compliance checking. However, that is just one part of the building regulations. Based on our analysis of several regulations around the world, it shows that figures account for 9 to 25% of the content in the regulation documents. This means that the current approach, which rely mainly on texture format requirements, overlook a significant portion of the regulation information. It leaves a critical gap in automated compliance checking research domain. So usually there are three different modes of requirements. The first one is the text-only case, which is widely studied case. And also there's a text plus figure combination case in which the key information for the compliance checking can exist in the both texture and figure representations. And lastly, the figure-centric case in which the key information only exists in the figure format. So to extract the rules from the figures like this, several traditional techniques can be considered. These include OCR to recognize the text embedded in images, or object detection and segmentations to identify visual elements, or the scene graph generation to capture the relationships between these elements, and or image captioning to produce semantically rich descriptions. So this kind of, based on this technique, the extracted information can be further utilized to create machine-readable rules. So about now, we are in the era of multi-large language models, which have shown remarkable capabilities in understanding and reasoning across both text and figures inputs, and also showing the many successful use cases for downstream engineering tasks. So already some studies have attempted to feed XML-based regulations and related figures into multimodal large language models. However, to date, there has been no quantitative evaluation of how well this kind of multi-large language models actually perform in rule derivation tasks. So therefore, the goal of this research is to evaluate the current performance and limitations of vanilla multi-large language models in deriving rules from figures to identify some kind of improvement areas for future development of our research. So we narrowed down our research focus to accessibility rules and choose to work with the text and figure pair cases to understand how visual information contributes to rule derivation part. Among the many figure types in regulations, we select these three representative categories to evaluate their individual impacts. So the experiment followed this structure. First, we collect a data set of regulatory figures pairing with text and manually created the corresponding Prolog rules, which is our target machine-readable rule format for this research. And next, we tested the three different input modalities. One is the text-only case and the figure-only case, and the text plus figure combination case. So the rules generated by multi-large language models were evaluated using both similarity score and F1 scores at the predicate and element levels. So finally, we conduct a qualitative comparison of the outputs to get a more deeper insight. So at the dataset collecting phases, we gathered a total of 23 text and figure pairs from various accessibility regulations and categorized that figures into these three representative types. So from the data set, one example from each figure type was fed into the prompt with a sample ground truth data for the in-context learning, while the remaining were used for testing. So this is the example of the ground truth examples, and the ground truth Prolog rules were created under the assumptions that all necessary information for compliance checking exists in the Prolog fact. Yes, this could be the too overwhelming assumptions, but in here, we just choose to focus on the rule derivation itself. And to guide the multimodal large language models behavior, we applied prompt engineering techniques, including role assignment in context learning and task definition, and also tell him to do some chain of thoughts, and also formalizing the input and output format. So this is the experimental result. After we analyzed the performance, the text figure produced the, so this is the experimental result from the experiment, and it shows the text plus figure combination part input case produced the highest performance case, while the figure only input significantly underperformed. This reinforced the idea that textual information is essential for the rule derivations, but figures can enhance rule interpretation when combined properly. So after we analyzed the performance, the difference based on the figure types, we found that the implementation examples had the lowest similarity score, and also the dimensional and annotated drawing case, on the other hand, showed a positive contribution for the rule derivations with a small performance increasing. So one interesting observation was that the text plus figure combined input case led to generation of more semantically meaningful variables. For example, instead of generic variable names, and the model-generated names like and distance from the real world, which are much more useful in the following a compliance checking context, such as preparation of model tests. So, however, there are still several challenges exist. Sometimes the single figure can lead to multiple rules, and it's sometimes redundant or irrelevant visual information becomes noise and degrades output quality. So for the conclusions, MLM, multimodal large language model itself can capable of generating rules from text plus figure in inputs, and there have some room for the improvements. And despite this finding, there are some limitations of this research, and I would like to address this kind of research with the following future work plan. So I would like to thank to this institute to support our research, and thank you for your attention today. I would like to have questions if you have any.